Bismillahirrahmanirrahim. Assalamualaikum. Today this is an additional slides regarding the construction of event trace analysis for chapter number 4. All right. I believe from the previous slide, I have given the structured step by step in order for you to construct an event tree, which is this event tree is one of the analysis for process hazard analysis. So we have other analysis methods, for example, HAZOP, fault tree analysis, and event tree analysis is one of them. Okay, so for this additional slides topic, I'll be explaining on the parts for the quantitative methods, which is to quantify the event tree or to quantify the risk analysis. Right. So you're just going to be fast on the overview because I've given the on the previous slide how to construct the event tree. So we have steps. This is going to be the step, the occurrence and frequency. So I'll be explaining on the occurrence frequency, mean time between shutdown, and mean time between runaway, and we'll look into the example of the event trace process, or how to quantify, especially the mean time between shutdown and the mean time between runway. Right. So as you know, accident is always happen. So I'm going to skip this. You can just read through this. All right. So for an event tree analysis, normally we have an initiating event. Right. So the main thing when you construct an event tree is an initiating event. So this initiating event must have been identified during HAZOP, right? So it usually involves a major piece of operating equipment or process step, example, a study knot. So example, when you construct an event tree, when you have an initiating event, the arrow, when you go up, the arrow for outwards is a success and downward is a failure, right? And also a circle is acceptable result and a cross circle is unacceptable result. So when you see, we'll go through an example over here. Okay, you have an initiating event over here. All right, when you have an initiating event, this is a value or a likelihood or a possibility or occurrence frequency for this initiating event to happen. So you have a value here, lambda A, right? And we have a safety function. For example, in order for this initiating event to happen, we have several safety function to happen. So this B, lambda B, is a failure for this safety function to happen. Right? So if you have an initiating event, if it is a success, you go up. Success of this safety function. Right? And when you go down, it's a failure of this safety function. Alright? So how to calculate this value is success of this safety function is lambda A, which is this value, times 1 minus lambda B, which is the opposite of this failure, is a success. And the failure is lambda B itself, the failure. So the failure of this safety function times the occurrence frequency, you get the failure. Okay, we go an example, then it's a bit easier for you to understand. Okay, however, you need to know there are three final results for the event tree. Number one is a continuous operation. Number two is a shutdown safely, or a runaway, or it is a fail. So whether the operation is continued, shut down safely, or a runaway or a fail. So these are only the three final results for inventory analysis. So what is the mean time between shutdown? So mean time between shutdown, MTBS is calculated is 1 over how many occurrence of a shutdown. And mean time between runaway is, it can be calculated by 1 over occurrence of how many of runaways or of failure. Okay, so let's go an example. You have an initiating event, which is the loss of a coolant to a reactor. So this is the initiating event. So we'll start with this loss of coolant to a reactor. This is your reactor. So the initiating event is the loss of coolant. Okay, so we have 4 safety function here. Number 1, high temperature alarm. Operator notice the high temperature during normal inspection. Operator re-establish the coolant flow, and operator perform emergency shutdown of a reactor. So these are all the safety intervention. So how do you construct this? Okay, before that, these are the value. The value of lambda A, loss of coolant is, occurrence frequency is 1 over 1 year. So this is lambda A. And alarm for the safety function to fail is 0.01. Operator notice high temperature, high reactor temperature, the failure is 0.25, and so on. So we extract all this information to an inventory diagram. Okay, example. This is an initiating event. Initiating event is the loss of cooling to a reactor. And you have 4 operating safety function, which is high temperature, alarm, alerts operator, operator notice high temperature, operator restart cooling, and operator shut down reactor. So this is the failure, that possibility of a failure for this to happen, which is 0.01, 0.25, 0.25, and 0.1. This is based on the question. So when you have this A, so you can divide into 2. Remember, for a success, it's upwards. For a failure, you go downward. So how do you get a success of the first one, high temperature alarm? So if the high temperature alerts the operator, which is a success. Okay, a success meaning this is a failure, which is that the high temperature does not alert the operator. This is how we call, right? So if the success is the 1 minus 0.01, you get 0.99. So it is a failure. So this is the failure of the high temperature fails to alert the operator. So you get 0.01. Then you go straight. For example, operator notice high temperature. Of course, when it is a success, of course, this also operator notice the high temperature. So you don't need to have a failure or a success over this step, the second step, this safety function in the second step. Okay, so you go straight and you go for the third safety function, which is operator restart cooling. If it is a success, you go up. So, and if it is a failure, you go down. So a success for this, if the operator success, so which is that A is 0.25, is a failure. So you get straight away to this continue, which is if the operator restart cooling and straight away operator shut down the reactor, you get 0.7.25. Right? And if you have a failure right now, which is 0.25 is here. 0.25 is a failure. But over here, the operator shut down the reactor. So if you have operator shut down the reactor, A times D, which is, what is A? A is the 0.7.25, 1 minus 0.1, and 0.2475. So when you have success, so you can continue the operation. If you have a success, a failure, and a failure, so it is a runaway, which is a fail. Okay, if you have a success, failure, but the operator shut down the reactor, managed to shut down the reactor, you get it shut down. All right. Okay, we go for downwards. If it is a failure, right now. So if it is a failure, so for this high temperature notice, you get 0.25 is a failure for the high temperature notice. So you get 1.25. This value is calculated when you have 1 minus 0.25, 1 minus 0.25 times 0.01, you get 0.075. The same goes to this. So this failure is 0.25 times 0.01, you get 0.0025. Okay, and continues along. Fail, success, success, continue operation. Fail, 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 run away. But fail, fail, at however last it can, the operator shut down the reactor, you can shut down. So you can classify this into three, which is continue operation, shut down, and a runaway. So you cross the circle if it is a runaway. So you have 1, 2, 3, 3 runaway, shut down, 1, 2, 3 shut down, and continue operation 1, 2, 3, 3 continue operation. So you total up for the shutdown 0.0227, all this, the value when you have times it. All right, I'll go for a simple one for you to understand. So we have example. Okay, we simplified this. Sorry, another one. Okay, this is another example. Easier one. The same thing, we have a loss of cooling. So the lambda A is 0.33. Okay, and success, you go up. For a success is 1 minus 0.001. This is the failure, so you get 0.99. Here is the failure, so the failure is 0.001. It's a failure. So we go straight for a success. This value for this a success for operator restart cooling is 0.8, because 1 minus 0.2, you get 0.8. So 0.8 times 0.99 is this value. 0.99 times 0.8. The same goes to here. 0.99, this is the value, times the failure, 0.2. And you get the continue operation. The same goes to here. If it is a failure, if it is a success, you go up. A success of operator shutdown is 1 minus 0.1, which is 0.9. So you get 0.9, which is here, times 0.2 times 0.9, or this value times 0.9. Okay, and this value is 0.1 is the failure, 0.9 times 0.2 was this value times 0.1. It's a, you can see it's a continuous right now. The same goes to here, you get 0.001, and the failure is, sorry, the success, you go up, is 1 minus 0.25. You get 0.75 over here. And this is the failure, 0.25 of this value. So it times the value of 0.001. And you go each one of it one by one. Okay, so you have continue operation, you have shutdown. If it is a operator lastly can shut down the operator, you can shut it down. And if it is a failure, so you have a runaway here. So you classify them into a runaway, continue operation, or a shutdown. So you cross mark it for a runaway. So how do you calculate the event A? What is A? A is 0.99. You can see 0.99 times 0.8, which is here, A, which is continue operation. Up, up, you get this 0.99 times 0.8. So you get this value, the end value over here, right? So you get event AD. What is AD? AD is a AD here. It's a shutdown. ADE is a runaway. ADE is a runaway. So AB is a continue operation. AB is a continue operation. ABD, you get shut down. Okay. This one, this one, this one. You need to follow the roots. Okay, you need to follow the roots, time the value over here. ABDE and ABC. So So you get this value for each one of the occurrence frequency. So you have each of these value. So what is the mean time between shutdown? So mean time between shutdown is 1 over how many shutdowns occurrence. Okay, you can see from this, what is a shutdown? Number 1, number 2, only 2 shutdown. So AD plus ABD. So 1 over 0.181798 plus 0.01358. So you get the mean time between shutdown is 5.5 years. And the mean time between runaway, so you total up how many runaway. Go back to the diagram, runaway. The diagram here is a runaway. So this value plus this value, runaway plus this value, runaway plus ABC, this value, runaway. So you get 1 over 3 values of runaway, you get 49.4 years. So mean time between runaway is how long before it can fill, 49.4 years. How long between shutdown is 5 years. So this have a rough an idea of the timing for this to occur. All right. So I believe you can read through the slides, try to understand, follow the step one by one. Okay, try to understand by following the line over here. Remember, success you go up, failure you go down. Okay, and try to do, if you have any question, just drop by or ask via the WhatsApp. Right, so with that, thank you very much.